All right, lab techs. Let's talk about something that's revolutionized diagnostics: multiplex lateral flow kits. These kits are changing the way we detect bacteria, viruses, and all sorts of pathogens, making testing faster, easier, and more accessible than ever before. Whether you're in a high-tech lab or a field setting, these kits are making a huge impact. You know those simple test strips in pregnancy or COVID-19 kits? They're everywhere, and for good reason. They're quick, user-friendly, and don't require fancy equipment. Now, imagine if you could screen for multiple bacteria at once, all on a single strip. No need for separate tests or complicated workflows, just one device, multiple answers. That's where antibody-based lateral flow kits with carboxyl latex beads come in. These kits are the backbone of modern rapid diagnostics, and they're surprisingly DIY-friendly if you know the basics. So, how do I make one? Let's jump in. The process is a blend of chemistry, biology, and a bit of creative problem-solving. It all starts with carboxyl latex beads. These are tiny polymer spheres, usually just a few microns across, but they pack a punch when it comes to binding proteins. Think of them as tiny, super-reactive ping-pong balls, covered with carboxyl groups. Their surface chemistry is what makes them so useful for diagnostics. Those carboxyl groups are like Velcro for proteins. They're ready to grab onto whatever you attach, if you use the right chemistry. To get our kit working, I first need to attach specific bacterial antibodies to these beads. The choice of antibody is crucial. It determines what your kit will detect. I use a coupling reagent. EDC is a classic choice. EDC, or 1-ethyl-3,3-dimethylaminopropyl carbodiamide, is a carbodiamide-based cross-linker that helps form stable bonds between the carboxyl groups and the antibodies. It activates the carboxyl groups on the beads, so they'll grab hold of my antibodies. This step is a bit like matchmaking, getting the right partners to stick together for the long haul. This step is critical. The accuracy of the whole kit depends on how well I immobilize those antibodies. If the binding isn't strong or specific, your test could give false results. Too loose, and I lose sensitivity. The test might miss low levels of bacteria, which could be a big problem in clinical settings. Too crowded, and well, things get messy. Overcrowding can cause non-specific binding, leading to background noise and confusing results. Now, once the antibodies are stuck nice and tight, I wash away any excess. This ensures only the properly conjugated beads move forward in the process. These functionalized beads are now the heroes of my kit. They're ready to seek out their bacterial targets with precision. I load them onto the conjugate pad, the part of the lateral flow strip that starts it all. This pad releases the beads when the sample is added, kicking off the detection process. The real magic happens when I add a sample. Whether it's a swab, a drop of blood, or a bit of water, the sample rehydrates the pad and sets everything in motion. Capillary action pulls it across the strip, sweeping my antibody-coated beads along for the ride. This simple physical process is what makes lateral flow tests so portable and easy to use. If the sample contains my target bacteria, those bacteria bind to the antibodies on the beads, forming visible complexes. The more bacteria present, the stronger the signal you'll see. When these complexes hit the test line, a second set of antibodies is waiting. These are immobilized on the strip and are specific for the same bacteria, ensuring only the right complexes are captured. They capture the complexes and boom, you get a colored signal right on the strip. It's a clear, visual readout that anyone can interpret, no special training required. Here's where multiplexing comes in. By designing the strip with multiple test lines or using beads of different colors, you can detect several bacteria at once. By using different colored beads or multiple test lines, I can detect more than one bacteria in a single test. This is a game changer for clinics, food safety, and environmental monitoring. Each color or line is like a unique yes-no for a different target. Efficient, right? It's like running several tests at once, but with just one strip and one sample. It's pretty wild, something this small, detecting so much information in minutes. The potential for rapid, on-the-spot diagnostics is enormous. Got questions about optimizing your kit or want to troubleshoot a tricky conjugation? Maybe you're curious about how to improve sensitivity or reduce background noise. Drop your thoughts in the comments. I love solving these puzzles with you. Let's keep pushing the boundaries of what we can do with lateral flow technology. Thanks for tuning in and happy testing. Stay curious and keep innovating in your lab.